degrees, the angle on the other shape will be 120 degrees. For similar figures, they're just slightly different than congruent figures. The figures are the same shape, but they're going to be different sizes. The angles will still be the same. So if you have two figures, and this is 120 degrees, the angle in the purple pentagon will also be 120 degrees. The side lengths will be proportional. Now, from our proportions unit, do you remember what proportional means? It means that they're related. So that means that one side here that corresponds to the side on the big pentagon will be related by a ratio. So if this is twice as big, the ratio will be 1 to 2, right? So if you have two shapes that are similar, you have special properties that you can use to be able to identify angles and lengths on each triangle. So if you have a similarity statement, triangle ABC is similar to triangle DEF, that means that you can conclude that the corresponding sides are matching and they are proportional. Because similar shapes always have the same angles, you can say that the corresponding angles are matching and they are equal. So just as a reminder, the angles inside a triangle add up to 180 degrees. So since a triangle is half of a quadrilateral, like a rectangle, what do the angles inside the quadrilateral add up to? Anyone? It's up on the board. Nope, a quadrilateral's angles add up to 360 degrees. So the total sum of all the angles inside the triangle is 180. And because the triangle is half of a rectangle, the angles inside a rectangle all add up to 180. So that's a nice relationship between the triangle and rectangle. So now we'll work through an example. So we have two similar triangles here. Triangle ABC and triangle DEF. So this angle A left corresponds to what angle on this similar triangle? B. This angle C corresponds to what angle? F. Okay. So now, if you're looking at the side DF, correct, and it doesn't matter what order you write it. And then if you're looking at CB, that corresponds to DF, correct. And then once again, because we know that angles for similar triangles are the same, angle B, if this is 87 degrees, what is angle E? Yes, 87, correct. All right. And we'll move on. There you go. Are two shapes similar? To determine if two figures are similar, you set up a proportion using the corresponding sides. So again, if the proportion should be the same for both sides. So we're going to call this triangle big. And we're going to call this one small. And so we'll set up a proportion. I will put my big sides on the top and my small triangle side measurements on the bottom. For the big triangle, I'm going to pick AC first. And so that one will be 45. And then I will pick AB next, and I'll say that's 42. For my small triangle, I have to pick the same side. So what side corresponds to AC? For the small triangle. Yeah, DF, that's right. So DF measures 30. And since I picked AB, what corresponding side am I going to pick for this bottom? Yes. DB. So that measurement is 28. So now if you cross multiply these, and you get the same answer, that means that these shapes are proportional. I mean, the sides are proportional, and it means that the shapes are similar. Okay, example 2. Again, we're going to set up a proportion using corresponding sides. So it's good to keep track of which shape has which sides. So it's useful to put a name to them so that you can keep track. So again, I'm going to go with my big rectangle on top and my small rectangle on the bottom. Now, does it matter which one you put on top and bottom? No, because you're cross multiplying, you should still get the same answer either way. And again, because we only have 2 measurements here, it's pretty straightforward. We're going to use RU and UT. So our measurements are 25 and 15. And again, you always go biggest to biggest and smallest to smallest. So BC will be our small measurement, and 9 will be the corresponding measurement. And then you cross multiply. So when you cross multiply, the product is 225 equals 225. So yes, these shapes are similar because they are proportional. So one of the nice properties of similar shapes is that if you don't know what the measurement of the side is, you can find it using a proportion. So in this example, we have a small parallelogram on top and a big parallelogram on the bottom. Again, you want to make sure that your measurements for each shape are going across your proportion. So our measurements for the small parallelogram are 8 and 3. And for the big is 12 and X. And so when we cross multiply, you get the equation 8x is equal to 36. And to solve for x, you divide by 8, and your answer is x is equal to 4.5. So you know that this side here is 4.5. So now it's always a nice spot to double check and see if your answer is correct. So think to yourself, okay, if this side is 3 inches, and let's see, the 8 and the 12, what side should this be? It should be bigger than 3, right? If you get an answer that's smaller than 3, then you know that something might be wrong if this is supposed to be a smaller parallelogram. So it's always nice to take a step back and double check your answers and make sure that they make sense. All right, example 4. So here we have a big triangle and a smaller triangle. And we'll be big and small. And when you're trying to find the missing side, make sure that one of your terms here is the x. Otherwise, you'll just be finding the ratio of the two, and you won't be able to find the x. So we know that the x corresponds to these 2 angles, which are equal to this angle and this angle. So we want to make sure that this is one of our sides. So for a big triangle, the other side, it really doesn't matter. I'm just going to pick the longest side. So for a big triangle, our numbers would be 10 and 6. And for a smaller triangle, the numbers are the measurements would be 4 and x. Alright. Then you cross multiply, and the equation you get is 10x is equal to 24. And you divide by 10 and you find that x is 2.10. So for our final example, we have two similar triangles. Again, we can do a big triangle, which is this larger triangle here, A and E, over our small. And for this one, the missing side is right here. It's BC, so we want to make sure that we include that in our proportion. So the proportions, the measurements I'll pick for my big triangle, I'll pick 15 and 10. For this triangle, it's pretty easy. There aren't any other numbers to pick. For a smaller triangle, our sides are 12 and x. So cross multiply, and your equation is 15x is equal to 120. Divided by 15, and x is equal to 8.